Hello everyone, my name is Mimi.
And my name is Laiba.
And we're here to talk to you about a cool fluid phenomenon that you actually observe in everyday life. Have you ever noticed what happens in your sink when you turn on the tap? What is shown in this video is called a hydraulic jump. What is a hydraulic jump? A research definition of that term is the hydraulic jump is a sudden transition from a high velocity open channel flow regime to a subcritical flow motion. But to put it simply, a hydraulic jump is a phenomenon when a moving fluid suddenly goes from fast moving fluid areas to flat or less steep slopes and slow moving fluid areas, and that sudden interruption of the two fluids causes the hydraulic jump.
For example, when you turn on the tap in your sink, the free-falling water that suddenly collides with the sink base will be slowed down and creates a jump. But that doesn't mean that the water doesn't appear before that jump area. There's actually a very thin layer of water inside the circle and a much deeper layer outside of it. It's a circular hydraulic jump where the film thickness changes. The jump doesn't happen right away. The hydraulic jump happens when there is already fluid on the flat surface. In this case, it doesn't happen right when the tap is turned on since the sink is dry. To understand the physics on how the sudden change in water speed can lead to a hydraulic jump, it's best to look at rivers, which is another very common place where a hydraulic jump happens that you probably didn't notice. As we learned in Module 2 in our Physics 131 class, Q equals AV. And to apply that to the river example, it'll be Q equals HVW, where H is the depth of water, V is the velocity of water, W is the width of the river. This equation is telling us the volume of water is flowing past the river, hence flow rate. Now, imagine a river flowing past you and suddenly the water dips down because there was a slope. So evidently, the velocity of that water must slow down, so V will decrease. However, the volume of water in that river doesn't change, and going down that slope, the water must continue to flow down the river, so the flow rate Q stays constant. And of course, the width W of the river stays constant. So therefore, the only thing that must change is the depth of water, H. So the height of the water must increase, just as the speed dramatically decreases.
Although to calculate the hydraulic jump is not this simple, and it requires a lot of numbers, which is more complicated, but to put it simply, there's a number called the Froude number that plays a big role in determining the magnitude of the hydraulic jump. The equation of the Froude number is Froude number equals velocity over square root of gravity times depth of flow. And if the number is greater than 1, it's a supercritical flow, which is normally rapid and unstable. And if the number is less than 1, it's the subcritical flow, which is stable. You might think the hydraulic jump is just a phenomenon that happens in fluid dynamics, but there's an important role for this cool phenomenon. The hydraulic jump is important in reducing energy and is commonly used in the engineering of downstream dams and spillways, which are used for a controlled delivery of water when the reservoir is full. It allows for those structures to not cause any damage to the surroundings from high velocity of water, the supercritical flow.
This is our bibliography, and this concludes our video. We hope that this video brought you some more knowledge about fluids and how the equation we learned in class can be used to understand much more things in this world. Thank you very much.